Okay, our next question is telling us we have a rectangular solid that has a mass of 14.9 kilograms and that it measures 4.3 centimeters by 10.6 by 13.6 centimeters. And it's asking us to calculate the density. So when I take a test, I like to underline or highlight what it is I'm looking for so I don't get lost in the math. And then I want my units to be in grams per centimeters cubed. So I've written here our equation for density, which is mass in grams over volume in milliliters or centimeters, because we know that 1 milliliter is equivalent to or equal to 1 centimeter cubed. All right, so we begin by writing what units we need on the left side of our equal sign. So we're looking for density in grams per centimeters cubed, and we know that because he tells us right here that we want the density in grams per centimeters cubed. So that's what we're looking for. Then we write down what's given to us, which is 1.490 kilograms. Okay, so we need grams on top. We have kilograms on top. We can get rid of that pretty easily. We know that in 1 kilogram, there are 1,000 grams. And now we have grams on top. We can cross off kilograms. And now we know we need centimeters on bottom. So the question is, can we just write centimeters on the bottom of these three equations? And the answer is you can. You just write a 1 on top, and we're going to write 4.3 centimeters times 10.6 centimeters times 13.6 centimeters. And that's going to give us centimeters cubed, because centimeters times centimeters times centimeters equals centimeters cubed. All right, now we're going to go over to our calculator. And we're going to close this ad. And this is where we're going to really utilize those parentheses. So we want to do parentheses on top. And we have two things. We have 1.490 times 1,000. That's all we have on top, because the rest is just 1 times 1 times 1. So we can leave that off. Close parentheses, divide by, open parentheses, and we have three things. We have 4.3 times 10.6 times 13.6, and close parentheses, we get 2.4036. We get 2.4036 grams per centimeters cubed. But this isn't our final answer, because we need to go to the correct number of significant figures right here. And you'll do this for every problem, even if he doesn't write it. You always want to go to the correct number of significant figures. So we have 4 sig figs, 2, 3, 3. So we want to go to 2 significant figures. Because we did multiplication, we know that we want to pick the fewest number of significant figures in the problem. So if we want 2, let's underline the 2 we want. I'm going to write 2 sig figs. So here's the 2 that we want. I'm going to look at one more. Does that do anything? It doesn't do anything. So our new answer is 2.4 significant figures, grams per centimeters cubed. And that's your answer for number 9. All right, number 10 is asking for the density of a certain liquid. Oh, it tells us the density of a certain liquid, and it wants to know, let's do this in a different color, what mass of the liquid would have a volume of 99.95 milliliters. So this question is worded a little weird, and it's not giving you the variables that you need in the order that you need it, so we kind of have to think about it. The first thing I like to do is, what is it asking? It's asking for the mass. And we know that density, let's write density, our equation again, mass over volume in grams per milliliter. So we need the mass. We know mass is in grams. We know that, so we can start right there. And it gives us the density. So let's just write the density down and see where the stoichiometry takes us. So we're going to write grams per milliliter. we're not going to write it like this. We're not going to write 0.785 grams per milliliter. We're going to write it on top and on bottom. All right, and it says would have a volume of 95.5 milliliters. So we want grams, and we have grams. We need to get rid of milliliters, and it gives us something in the problem. It gives us milliliters. It gives us 95.5 milliliters. And so now I can cross off my milliliters and do my arithmetic. So we'll go over to our calculator, and we will clear this. And let's see, it was 0.785 times 95.5, which gives me 74.9675. 74.9675 grams. And then how many significant figures do we have in the problem? So we have 3 here and we have 3 here, so we want to go to 3. So let's underline the 3 we need. Look at one more. And that 6 does change that 9, which does a domino effect. And so we're going to get 75. That's only 2 significant figures. But if I put a decimal and a 0, now I have 75 grams. That's our answer. But there's another way you could solve this. So I'm just going to erase this stuff really quick. So we use the stoichiometry route and we let it kind of map our way through it. But what if we wrote down all of the variables that are in our density equation? And what if we put the numbers from the problem next to those variables? So we know our density is 0.785. And we know our volume is 95.5 milliliters, and we're looking for mass. So we can change this equation so that mass is equal on the left side of the equal sign. And we do that by multiplying out our volume. And what we do on one side, we have to do on the other. So then we get density times volume equals mass. And then you can just plug in your numbers and do density times volume, which is essentially what we did with the stoichiometry. All right. We have time for one more problem on this video. It's a piece of metal has a mass of 245 milligrams and a volume of 15.3 milliliters. What is its density? And it gives us the answers in grams per centimeter cubed. And we already know that 1 milliliter equals 1 centimeter cubed. Here's our equation. So all we're looking for is the density. So we just do density equals mass, 245 milligrams. And it's going to be, we need it in grams, right? So we got to get rid of our milligrams. We know there's 1,000 milligrams in 1 gram. Okay, now we have grams on top. In fact, I broke my own rule. That's right, grams per centimeters cubed. Okay, so we have grams on top. And now we need centimeters cubed, but we can stick with milliliters for now. We know it has 15.3 milliliters. And then just go over to our calculator. And here's another good time to utilize your parentheses. Oh, let's go over here. All right, so we have parentheses 245, and that's all that's on top. And then we're going to divide by 1,000 times 15.3. We're going to get 0.0160. 0.0160, and that's grams per centimeters cubed. And then how many sig figs do we have in the problem? So we have 3 and 3, so we want this to be 3. I'm going to rewrite it. Okay, so we want 3 significant figures. We know this and this are not significant because they're leading. So we're going to underline the 3 that we want, and we're good. We have 3 significant figures, so our answer is D.